Do you have an iOS app that you desperately want to bring to the Mac? Or perhaps you want to start a new app supporting multiple platforms from the get-go? Stay with me because in this video I'm going to share with you some of my tips and tricks on that regard, and who knows, maybe you will find something useful in there. Let's separate this topic into two parts. First, let's see some of the options when you want to port an iOS app to the Mac. The reason why I wanted to start with this topic is that it has the most amount of details to it. You see, when developing for the Mac, you have basically three options. These can be seen in the supported destinations sections in Xcode. Open your project, select your main target, and go to the General tab. The configuration you see here is pretty much the default one when you create a new project, at least in Xcode 16. As you can see, some kind of Mac support is already turned on by default, but to see all the options, go ahead and click the plus button in the bottom left corner and hover over the Mac option. As you can see, we can choose between Mac, Catalyst, and Designed for iPad. But what are those options? Let's see. The simplest option is the one that's turned on by default, and it's Mac Designed for iPad. All it does is it allows your app to be run on any Macs with an M series chip. Nothing more, nothing less. Let's go ahead and run the project to see what this means in practice. As you can see, our app runs just fine, but if you look a bit closely, you'll find that some things are off. UI controls look just like on iOS. The frame, the window, everything is just a bit out of context. And while this is not really visible on the YouTube video, if you tried, you would notice that scrollable surfaces can also be dragged, just as on the iPad. It may already be clear to you that this option is pretty limiting. Not only that the UI is a bit out of place, but you can't use any Mac APIs, for example. The pro, however, if using this method is its simplicity. You can literally make your app available on the Mac with just a few clicks. In my opinion, this option is perfect for low-profile apps that don't really require any special Mac APIs, and you just want to make it available to your users on their Macs, and that's it. If you've been around developing for Apple platforms for long enough, you should be already familiar with UIKit and AppKit, Apple's previous UI frameworks. Unfortunately, these two frameworks are not really compatible with each other, meaning you cannot use AppKit on iOS and UIKit on the Mac. Mac Catalyst is this intermediate option designed to overcome this issue, or at least make it a bit simpler to overcome it. By enabling Catalyst, you can design your app a bit more specific to the Mac. Let's see how this works in action. Go ahead and remove the previous Mac option, then add Catalyst. Xcode will ask you if you want to enable it, and just say yes. If you go ahead now and run your app, you will see that the whole structure, the window, the sidebar looks a bit more like a Mac app, but the UI controls are still the same. Let's change that. Go to your deployment info and change the Mac Catalyst interface option. As you can see now, your UI is completely native to the Mac. So, what are the pros and cons of using Catalyst? In my opinion, Catalyst is a perfect tool to bring any iOS app to the Mac that already has a complex UI built on top of UIKit, or if you just want to stick to UIKit for any reason for your new project. While using Mac APIs is possible through Catalyst, it's a bit more limited, so if your primary way of building UIs is SwiftUI, I would think twice before deciding whether to go with Catalyst or with the next option I'm going to present. Finally, let's see our third option, the native Mac support. Once again, go ahead and remove Catalyst from the target destinations and add the native Mac. If you run the project now, you will see that your app behaves exactly like any other Mac app, because it is a Mac app. At this point, if you are only using SwiftUI, you may already be good to go. The native Mac destination allows you to use any Mac APIs you want, and SwiftUI ensures that all your UIs at least work on both platforms. You may still want to customize your UI based on the platform, but more on that later. First, let's see the biggest disadvantage of using this method. Let's have a quick look at this UI view. As we all know, SwiftUI is still fairly new, and sometimes we just cannot work around having to go back to a good old UI view for some reason. You see, this UI view compiles just fine on iOS, but as soon as you switch to a Mac target, you will start getting errors stating that UIKit doesn't exist. As I said before, UIKit is not available on the Mac, so for something like this you would have to use AppKit on the Mac. Let's see how that's done. There's not much that you have to change to make this compile on the Mac, however your problem is not completely solved, because now it compiles for the Mac, but if you switch back to UIKit, you have the same error, just the other way around. And this is exactly the biggest disadvantage of using the native Mac support. You'd have to write a lot of code just so you get more or less the same results on both platforms, but I guess that's just the price we have to pay to get the best results on all devices. And now in the second part of the video, let's have a look at some of the options we have for solving the situations we have with UIKit and AppKit here. One of the simplest solutions is using compiler directives. They are an extremely useful tool for controlling how your compiler will turn your code into a compiled application. For example, including or excluding some bits of code based on the operating system you're targeting. If we go back to our UI view, we can put our failing code in an if block, and we can even provide the fallback option. Notice how Xcode gives your inactive code a lower opacity, making your active code more prominent and easier to read. Also, a quick side note here, you may have noticed that I've specified macOS as my condition, not iOS, and that's because there are a lot more platforms that are using UIKit than AppKit, so by specifying macOS and having a fallback will guarantee that I can use my view on multiple platforms in the future without having to change a lot. An alternative to the if directive is the can import method. This will check if a certain module or package can be imported in the current context. This can make your code more robust and more platform independent, but at the end of the day it's more like a preference thing. Let's go ahead and add some more ifs here and there just to make our whole class compile on both platforms. While I'm doing that, please note that whatever compiler directives I'm adding, they are evaluated at compile time, hence the name. Which means that you are the one responsible for making sure that all possibilities work well with the rest of the code, which is common. One workaround for making your life easier working with both UI and NS views is making use of the fact that their APIs are very similar. It doesn't work all the time, but in many cases you can make a type alias for one of the NS views or UI views to the other one and just use that in the whole code base. But be cautious with this method because you are entering the world of little hacks here and there. And the more of these you add, the less maintainable your code becomes and the more error prone it will be. Even though the APIs of these classes are very similar, many times the underlying implementation is different, and if you're not really familiar with these, you can end up with small hidden bugs that will be really hard to find. Just to mention one of the more well-known differences, UIView and NSView handles their coordinate systems completely differently. UIView has its origin in the upper left corner with positive Y values going downwards, while NSView has its origin in the lower left corner with positive Y values going upwards. If you are using a type alias for NSView, for example, and you're positioning views by their coordinates on the screen, you can end up with pretty interesting results. So back to our view. As you can see, this file compiles now just fine on both platforms, but still there's a tiny bit of inconvenience. And that is, it's pretty hard to read and maintain nonetheless. And it's just a tiny little view. Imagine having lots and lots of complex view hierarchies full of these compiler directives. It's not very nice. Before we talk about the last option that you can use to solve this problem, let me show you one way to mitigate this. If you find yourself having a lot of compiler directives in one class, try to wrap your whole class in an if and provide the fallback for the other platforms. As long as you keep all your public-facing APIs of the class the same on both branches, your common code will know nothing about the underlying implementation details. And that is exactly why this method is pretty dangerous, so be cautious. The more workarounds of these you add, the less maintainable your code becomes. So I'm not saying you shouldn't use them, just make sure that you know what you're doing. Our last option is adding a separate Xcode target for our separate applications. You may already know about Xcode targets. They are a pretty powerful tool to have different configurations for different versions of your app. And this is exactly what we need here. Go ahead and delete your Mac destination for the supported destinations of your main target. Then, from the lower left corner, click the plus button. Choose a macOS app and hit save. This will create a new target for your macOS application as well as a new group or folder in your project for your files specific to your Mac app. Great! From this point you fully unlocked control over your app. You can do whatever you want specific to the Mac and whatever you want specific to the iOS. But what about our view? Well, before that we still have some things to do. You see, when you are working with different targets, the way you make sure that some code is included in the building and other is not, is to make sure that the file is part of a certain target. Right now, all our files are only part of the main target and not on the Mac target. So select all your files that you want to be part of both targets, then from the right side inspector locate the target membership and make sure that you have both targets there. If a file is not included in a certain target, at the compilation of such a target, the file will not even exist for the compiler, which is a great thing for our case. Now that we have this in place, we can go back and fix our view. Select the file the view is in and make sure it's only included in the iOS target. Then go ahead, open the file and remove everything Mac related. Now go ahead and add a new file to your Mac targets folder. You will see that at this point you can already choose which targets your files should be a member of. And that's it. Now you have a fully customizable cross-platform application. But what's all this drama if you have SwiftUI anyways? Well, you see, UI is not everything. There are many things in the business logic side as well that you may do differently on iOS or on the Mac, or that are not even available on one of the platforms. But even if you are only talking about UI, there are a lot of things that SwiftUI just cannot solve for you. Each platform has its ways of doing some things, and you just have to adapt to those. Take for example window management. While SwiftUI's sheet modifier works well on both platforms, a sheet is certainly a lot more limiting than a macOS window. But you can't just rely on Windows because that behavior is not even defined on iOS, so what do? This is exactly the situation I had to deal with one of my apps, Mockamatic, which allows you to create small deb servers to test your API integration easily. At one point in the application you can add a server, which on the iOS is a sheet, and it works fine, but on the Mac I wanted to make use of the possibilities of a Windows, so I had to come up with code that on what platforms presents a sheet and another one opens a window. And finally, before we end this video, I wanted to talk to you about how you choose which option is the best fit for you. While I always say that you start from the easiest and work your way up on demand, it may be worth it to think through from the start what you are going to build, because it's a lot easier to build it right from the start than to adapt it later. There are many things that you cannot do with one or the other option, so you should think through before committing to any of these. Thank you for watching this video, I hope you find something useful for you in it. Don't forget to leave a like for the YouTube algorithm, and if you have any other tips or tricks that we didn't talk about, leave a comment below. Let's learn together. Until the next one, take care.